All right, I'll go ahead and get started. I'm gonna see if I can actually get us back on track. So I'll just talk fast. If you have any questions throughout, please interrupt me. I might be making certain assumptions about knowledge that are false because this is kind of a niche topic in some ways, and it's hard to draw the line at like who knows what, right? I'm talking about DNSSEC. So what is DNSSEC? I think we all know what DNS is. It's the infrastructure that allows us to look up a name and figure out what IP address it points to. The problem is, what if the person giving you the IP address is a liar? What if you're in Starbucks and someone has man in the middle of your connection, and you've got a malicious name server that's actually returning that bankofamerica.com points at this IP, and actually it's a bad guy. And obviously that happens. We hear all the time like, ooh, don't connect to Wi-Fi you can't trust and such. And so the problem of actually securing DNS is a real one and an important one. We obviously have other solutions and other protocols, things like, obviously like TLS. And in fact, DNSSEC is going to be sort of the same kind of answer to that. So DNSSEC was created in 2005, the original specification. And the whole idea is that it's meant to prevent spoofing of DNS responses, so that you always know that when you get back an A record or a whatever record, that it has been signed and authenticated, and that it's actually coming from the authoritative name server that owns that domain. And much like TLS, DNSSEC relies on a public key infrastructure. It's really not that different from the idea of X509 and sort of this idea of having cert certificate or root certs and intermediate certs and actual site certs. The difference, of course, is that DNS is inherently hierarchical. So it's actually the biggest problem with TLS is how do we figure out what a root cert is? It's that actual original key distribution. And so DNS sort of solves that from the get-go because it's hierarchical. IANA, whatever you want to call it, is the owner of everything, which is the root zone of all domain names. Ultimately, every single fully qualified domain traces its lineage back to . And so IANA can sign everything underneath it, right? And those are like your TLDs, which are com. edu. Org, so on and so forth. And then that follows down naturally, right? Where you have Microsoft.com, that's a new zone, and then everything below that, like ftp.microsoft.com, is its own zone. And so you can always say that in DNSSEC, a record is always going to be signed by the parent in that zone or for that zone. And so if you have a website like mybank.dom, that record, when you actually query for their A record, will have a signature that's signed by .dom. And then when you query .dom, you get a signature from . And so that you only need one key, and from that the whole internet works, right? Interestingly, just this week, IANA rotated out their signing key for the first time in 11 years, which is interesting. As information security professionals, the idea of having an extremely important key that you only rotate every 11 years is weird, but I guess it's like really convoluted. Like, they actually had like two guys carrying smart drives around and had to physically put the new key in, and it's like this whole process. So maybe that's why they only do it every 11 years. But I just thought that was interesting because that means that if the key's compromised, it's going to be a long time before that gets fixed. So yeah, it's been 11 years. So we should expect that DNSSEC is widely adopted. Obviously, the problem of securing our DNS infrastructure and proving that records that we get are correct is really important. So since we have a solution, everyone's using it, right? I mean, we should be at that point in the adoption curve where it's been widespread. Well, that's wrong. And we're going to talk about why. Officially, DNSSEC is widely adopted. So this is 2006. You can see that it's experimental in some places. They're starting to put it into the root. So you have at IANA, and then different countries will have their own country TLDs, or for example, ARIN, which is the registry for North America, might own certain other TLDs, and so so it has to trickle down, and so this is 2006, and this is today. So DNSSEC is everywhere. So I guess problem solved. I'm not sure why I'm here, but actually, nobody uses DNSSEC. The reason I even got interested in this at all. So one of the things that we do at my company is we provide risk ratings on companies so that you can see like what their security posture is from the outside in. And we're like, oh, well, what's a good metric? Let's see if they protect their domains with DNSSEC. We have all of the big companies, and like that's a good differentiator. Whoops, no, it turns out that like 2% of companies implement DNSSEC. If you look at like the Alexa, like Fortune 500 or like the Alexa Top 1000, nobody uses it. It's like 1 to 2%. And so the question is why? Like if the problem that DNSSEC solves is important and it solves it, what's slowing down adoption? Well, there's a lot of things, but the main thing we're going to focus on today is called NSEC. And so this is a type of DNS record. So NSEC records for a DNSSEC protected name point at the next node in the zone and the previous node in the zone. One of the requirements of the DNSSEC specification is that if I query you for a name, you have to tell me that it does not exist. And so the way we prove that a name doesn't exist is we tell you the closest name behind it and the closest name after it. And so you know that there are no other names in between. And so that solves that problem. And so DNSSEC or NSEC records form, like a circular linked list that allow you to walk a zone. And if any of you guys are pen testers here, you probably can understand the value of that. I'm sure that when you're doing recon, some of you probably try to do zone transfers, right? Which have been disallowed for an extremely long time. What I'm showing you here is actually, this is PayPal. They're one of like the few like really big guys that actually do enable DNSSEC. And so it's trivial to just walk their entire zone. I can get all their domain keys. I can get every single server that they have on there that their name server manages. And some of those are things that they want us to hit, like www.paypal.com. Other things, not so much. And
it's under public zone, though. It's public information. Like, it's not exposing anything that shouldn't be disclosed.
I would dispute that. So that because you could say the same thing about zone transfers, right? But the reality is that just because I have a house on the street doesn't mean I want to be listed in the phone book. I don't necessarily want you to be able to look me up.
Right, but then you put those on servers that aren't queryable from the world. I mean, the bigger way that I get internal information is through certificate transparency.
Right, yeah.
Which is completely separate from DNSSEC, so I don't see the big security faux pas with this.
Well, I think just the big faux pas is that it allows total zone enumeration, and that's something people don't want. Like, I address this later. Like, yeah, some people say, well, you're using DNS wrong. If you don't want your stuff to be enumerable, then don't put it on public DNS infrastructure, right? There's other ways to do that. You can have like split DNS where you respond differently to, to queries in different locations and so on and so forth. But obviously that's a lot harder to manage. And the reality is that this is how people do use DNS. And so we can't just wave it away and say it's not a problem. It's so much a problem that everybody disables zone transfers. In North Dakota, they actually ruled that trying to do a zone transfer on a zone without permission is against the law. So it stands to reason that we do feel that zone enumeration is a problem and we should address it, especially if it's not actually necessary to solving the problem of securing the infrastructure itself. And the reality is that having that zone, so one of the things that we do, the reason, at our company is we try to enumerate, a company's entire digital footprint because you want to understand what their actual attack surface is. And being able to do NSEC walking makes that trivial, like compared to any other technique you could use. You literally can, this is, what I showed before was literally just the output of an Nmap script that allows you to pull an entire zone, and now you know every single host, and their addresses, and you can start looking at, running further stuff like Nmap to actually figure out what are the open services and so on and so forth. So in some sense, it's security by obscurity, right? But we need everything we can get. So if there's not a compelling reason to, like, prevent zone enumeration, we probably should. And this was something that we'd already, like, protected ourselves against, right? When we disabled things like zone transfers, that was an implicit statement that we don't want our zones to be enumerated. And so the fact is that it's going to stall DNSSEC adoption, and has. That's like by far the largest reason. I mean, if you do any research on DNSSEC, this is why people don't want to do it. And so there are proposals to mitigate that. Ironically, the idea of having the entire zone be enumerable was considered to be a benefit in the specification, which to me really just speaks to the fact that the people who come up with these specs are actually disconnected from the way the systems are used. And so that's actually the most important takeaway that I'd like to leave you guys with, is we, as security professionals and people who actually use the systems and understand how they're used and how they're exploited, need to be involved in these conversations, because whoever came up with the specification was like, this is great. This way everyone can see exactly what's in a zone and never be worried that they're getting a false record. But didn't think through the actual implications based on how the real world works. But that's the problem. So now what do we do? There's a couple interesting potential solutions. One of them is this idea of white lies, so the idea is that when I query a name server, I have to know if that name actually exists or not. And so with NSEC white lies, what they do, instead of telling you the first and the last zone, or the next and the previous zone, is they make something up. They'll like do an offset, so that you still know that that name doesn't exist, but it didn't actually leak information. The problem with that is that, again, it doesn't match the way we use DNS, because DNS servers are typically really stupid. They just have a zone file and they're just pulling from that, and that's all you get. If you need the DNS server to actually make stuff up and sign things on the fly, now you're having to store signing keys on your DNS servers, which is bad. In a sense that now you've opened yourself, you've widened your attack surface, and it's also just adding like processing overhead that didn't exist before. So while the idea of white lies does solve the problem of zone enumeration, it's not really compatible with the way that DNS is traditionally deployed. Unfortunately, we don't have any real alternatives to DNSSEC currently in terms of actual technologies. One of the biggest is DNS curve, which is just the idea of encrypting actual transactions with servers, with name servers. But then that leaves us to the original problem that TLS has, which is, well, how do you distribute keys? How do you know who to trust? And you lose the entire idea of the hierarchical key signing that you get from DNS. So DNS curve is not really a way to go. What we talked to is that some people say DNSSEC walking is not a weakness. You're just using DNS wrong. And while that's fair, it doesn't solve the problem, right? If you don't want something to be publicly addressable, then don't put it in a public place. But we do, and we have, that's how everything works. So how do we fix it is really the question. And how do we make things secure given that constraint? So there are some other solutions, so NSEC, so the problem with NSEC, right, is that it just returns to you what the next name is. NSEC 3, it returns a hash. The problem is that they tell you what algorithm they use to hash it, and they give you the salt, and the salt can be 0 characters. So it's actually really simple to come up with a rainbow table for NSEC 3 hashes, particularly because, you can enumerate all the hashes, right? And you can already guess what some of the names are going to be. Everyone has www or www, right? So then, like, since you can do a pretty targeted dictionary attack, you can end up actually figuring out ways to break NSEC 3, and there's been demos and talks of that. NSEC 5, which was proposed in 2015, uses basically, I forget what the hashing scheme is exactly. But it provides provable protection against enumeration. The issue, of course, is that it's not very old. It was basically in an academic paper in 2014 which means nobody's implemented yet. Cloudflare takes a really interesting approach. So, like, I mean, they control a lot of DNS at this point, right? You know, people like them and like Akamai and like all of the CDNs, you know, they're actually managing a lot of, like, you know, the internet's traffic, and so they take this approach that they call black lies, where instead of you know, giving you the next record, they just sort of make something up in a deterministic way so that they don't actually have to do a database lookup, and they can just, so like if you look up for a name that doesn't exist, they just they give you an NSEC record for a fake record that is derived from the record you suggested. And so instead of having to do the expensive work of actually having to generate on the fly, or actually having to store signing keys on the name server itself, they're taking this other approach, which also results in much smaller responses, and that seems to work for them, and is also fits into the specification of DNSSEC. So they actually have a draft out for preventing zone walking via black lies. They write some pretty interesting articles on how they handle DNS at scale. Yeah, so that was NSEC, and then like another issue that is you know, not really related is just the issue of amplification, which in some sense NSEC does have to do with this, but when you add signing and you add, you know, large keys, your DNS responses end up being way larger than they used to be. And so that actually makes DNSSEC a really common vector for DDoS amplification attacks. You know, via reflected DDoS attacks, because where before I would query a name server and the response that comes back is, you know, maybe 300 bytes, now it's well over 1,000, you know, because of all of that overhead of the signing. And so that just makes DNSSEC actually a really interesting vector for amplification attacks. And that's another reason why people don't want to adopt it. So, yeah, I guess what I'm really getting at here is that ultimately securing DNS is a non-trivial problem. It's not entirely clear how we're going to solve it. The most important thing to consider, I think, is that we as security professionals need to be involved in those conversations so that we can actually guide some of these specifications to fulfill the real operational needs of what DNS needs to do versus just what some people think it should do, right? Any questions? Yes?
One of the weaknesses that I've heard about is the fact that the United States effectively controls the root keys of DNSSEC, and from a nation or nation-state type threat model, that's a weakness. So where do you stop at that?
Well, I mean,
U.S. doesn't control that.
yeah, I mean, the root key is controlled by IANA, which is not a government entity. It's a, you know, it's a private-public collaboration, right? I mean, and all of like the NCCs, like ARIN, RIPE, you know, APNIC, they all fall under IANA. So I don't know that that's, but at the same time, right? You could say that about like Google and Yahoo, and we saw how that worked out. So it's not a totally unfair concern, but I don't think it's a particularly legitimate.
In other words, do you think that a nation state has the capability to spoof DNSSEC?
No, because like I said, the root key is IANA's. It's not country specific. A country could spoof any of the DNSSEC responses under its, you know, country TLD. But I mean, you know, for countries that are doing that anyway, they already have such crazy control over, you know, the packets on their networks that I don't think that really matters. Any other questions? Yes.
So what is your current recommendation? Do you not deploy it, or deploy with certain settings? Or?
So I think you can't blindly deploy it. You have to actually have the right systems in place so that DNSSEC works with what you want to do, so that things like zone enumeration, for example, don't affect you. Or you're doing things like what Cloudflare is talking about, like, you know, with their black lies approach, or by implementing NSEC 5 to prevent you know, that sort of thing. But the vast reality, almost everybody right now deploys either just plain NSEC or NSEC 3, and so that leaves them potentially weak. Yes?
So I work for the federal government, which is mandated to run DNSSEC on all public-facing government zones. We don't have choice.
Yeah, which is super handy because it makes it really easy to like enumerate like agencies.
We've been DNS AMP before plenty of times, and DNSSEC adding on quite a bit of size of the package we're putting back in. But do you have a write-up or recommendations on best practices for DNSSEC for the people that don't have a choice but to run it?
Yeah, so I would gladly point you at some of the stuff that Cloudflare has written up specifically about DNSSEC and how to mitigate some of the problems with it. And also, I mean, they're extremely concerned about like DNS, amplification attacks, and so they talk about that to some length as well. I'd be happy to if you give me your card or whatever, I'll shoot you some articles over it. I think would be pretty helpful. Yes.
I have a question. So, in terms of the whole white lies and black lies approach, how, let's say from a attacker perspective, how would you distinguish that from something like the domain generation algorithm returning a text?
What do you mean exactly?
So, let's say someone...
You mean like a wildcard?
Yes.
Well, like if you actually have a wildcard, that's part of your NSEC response typically that would actually tell you that that's where the wildcard fits. So you like a system that's naively implementing it, NSEC will actually just tell you that it's doing wildcards. So this would be different in that you wouldn't know that. Like for example, Cloudflare strips that out completely so that you can't know that.
And what about subject alternative names, like for a service?
What do you mean? Because that's TLS. That's not
right. I don't know. I guess what I'm trying to get at is like, what if there's a way to easily enumerate I guess it's sort of like a domain generation algorithm for the white lies or white lies approach.
Yeah. So what you're supposed to do for the white lies approach, right, is that if you have because like what you use NSEC 3, you return hashes, right? So if somebody asks for a.b.com, you, instead of pointing them to the actual next record, you take b.b.com, and then you hash that, right? And so your hash is like, obviously, not related anymore. And so theoretically, you shouldn't be able to follow that. The problem there is that means that your DNS server needs to have the signing keys to be able to do that. All right. Well, I think I almost made it into the original time window. So thank you so much. If you have any other questions, I'll be outside. Thanks for your time.